You're listening to EUAudio. Listen, learn, lead. Sensing danger before it happens. Why sensors hold the key to a streamlined predictive maintenance strategy. Unplanned machine downtime costs the world's manufacturers over $50 billion a year, with a major cause of this being unexpected equipment failure. How can modern sensor networks reduce unplanned machine downtime in the manufacturing industry? In the early days of the first industrial revolution, machines were not complex compared to their modern counterparts, and this meant that there were fewer complicated breakdowns and less downtime. As the world entered the second and third industrial revolutions, the introduction of assembly lines and automation increased complexity, and in doing so increased the amount of breakdowns. As we enter the fourth industrial revolution, or Industry 4.0, manufacturers are now focusing on equipment availability, operational costs, and worker productivity. Currently, in the process industries alone, the average yearly cost of unplanned machine downtime is estimated to be approximately $20 billion, which is around 5% of total annual production. This is mostly because of lost sales, idle labour, and the cost of spare parts. Furthermore, there is a risk that the unplanned downtime can lead to lasting equipment damage, environmental harm, and the endangerment of workers. Manufacturers can respond to this using Industrial Internet of Things sensors to implement predictive maintenance approaches in the factory. It is estimated that using IoT sensors in factories in this way can increase productivity by 30%. Predictive maintenance differs from preventative maintenance because it relies on the condition monitoring of equipment in real time, compared to average equipment lifetime statistics. The condition monitoring data is used to predict when maintenance will be required, so it can be carried out before the faults cause expensive unplanned downtime. Predictive maintenance strategies often use infrared sensors, acoustic monitors, and vibration analysis to monitor asset performance. These are all normally implemented on a wireless sensor network within the facility that is used to collect and transmit the sensor data in real time. This enables machine operators and facilities managers to make key decisions with minimal delay. Manufacturers are increasingly adopting IoT sensors to collect data within their factories. The data harvested from these sensors can be used to monitor asset performance and, through a series of algorithms, detect potential faults in the system before expensive downtime occurs. Compared to conventional reactive approaches to maintenance, this type of proactive, predictive maintenance strategy is both time-saving and cost-effective. Wireless sensor networks can be used to transmit the data of thousands of autonomous sensors, each monitoring a physical or environmental parameter within the facility. Compared to a traditional wired network, wireless sensor networks offer two key benefits. Firstly, they offer significant cost savings compared to their wired counterparts because they don't require large-scale infrastructure work to install within a factory. Secondly, wireless sensors can be placed in locations that are not accessible to wired sensors, such as rotating machinery or untethered autonomous vehicles. The networks are comprised of nodes, with each individual node connected to one or more sensors. Typically, network nodes are made up of a radio transceiver, an internal antenna or a connection to an external antenna, a microcontroller, an electronic circuit for interfacing with the sensor, and a power supply, which can be either a battery or a mains connection. Predictive maintenance relies on the data gathered by these sensors to provide decision-makers with the key information so that they can fix problems before they cause expensive, unplanned machine downtime. EUAudio is brought to you by EU Automation.